Good morning, good afternoon, or good evening, wherever you're watching us. We certainly hope that you've been enjoying our earlier videos on gloves and masks, right? And, as we're sort of exploring our series of, polymers that we encounter in everyday life, polymers that keep us safe and healthy, we're going to continue that series today. Today we're going to mostly look at personal protective equipment, and we're going to continue our series of polymers and personal protective equipment. PPE is ubiquitous, for safe workplaces and other situations where we might be encountering biological, chemical, or physical risks. Especially now with the COVID-19 pandemic, PPE is as, if not more important than ever to keep us safe and mitigate the spread of the virus.
Right, so as we've gone over in our last few videos, we've looked at PPE, right? So we started with gloves, so it's how to protect yourself from what you're working with, let's say in the laboratory, whether it be dangerous chemicals or maybe it's pathogenic material. We looked at masks in terms of whether you're in a laboratory or you're in a work site and trying to prevent yourself from inhaling either dangerous particulate matter or again, pathogenic or infectious materials. So today what we're going to do is we're going to continue our discussion of polymers for PPE, and we're going to focus on eye protection.
Right, that's really great. So when do we imagine using eye protection?
Well, so eye protection is critical because we use our eyes for so many tasks, whether it's from driving, reading, navigating, really so many of the things that we do in everyday life, it counts on using our vision. And so protecting that is supremely important. So we need a way of effectively protecting our eyes against things that can damage them. So whether it's harsh chemicals in the lab, such as organic solvents or acids, or even impacts from objects, we need to have something that we can see through, but that will actually protect our eyes. We also can need or use eye protection to limit the spread of diseases, since a number of infections or infectious cycles can actually start when a pathogen enters through the eye.
Yeah, that's really interesting. So today, we're going to be discussing distinct and different types of eye protection. So these can include non-corrective safety glasses, right? So these are lenses which have a sort of conformal shape, right? They sort of meet the eye, and they're sort of effective at blocking liquids and droplets, that we might be encountering.
So the next level of protection beyond safety glasses, right, would be safety goggles. So sort of the comparison here is if I'm wearing these safety glasses, while they protect me from droplets or materials immediately heading towards or hitting your eye, there are spaces both underneath and the top, and then also sometimes on the sides of your eyes here as well. So what we do when necessary is we move to a bit additional protection using safety goggles, and so it'll actually have this material here that'll actually form a almost like a seal against your face. So if I put this on, now I can see through these again, but now I'm protected from material coming in from the bottom or the sides or the top. So these just provide more of a tight seal around the face and give you a greater protection. Beyond that, there's another level of protection you can get, and that's by using a face shield, such as this one. So if I put this face shield on, for example, you can see that not only does it protect the eye, but then it also protects other parts of the face as well. So having looked at these different types of eye protection, whether it's a face shield or safety glasses or safety goggles, really the next question we need to ask is, what are the sorts of properties that we will want these materials to have?
Yeah, that's actually really important to think about. If we're looking at glasses, right, we're going to want our glasses to be rigid and moldable, and typically they're made of polymer, right? We want our glasses to be able to maintain a structure over time, even as we're moving around doing our tasks, right? We don't want our glasses to change shape as we're actually performing our activities. Rigid materials, also offer protection against loose or flying debris people might be encountering, right? So if we're working on a construction site or even occasionally in the laboratory, hopefully we don't have a lot of objects flying around, but these are things that could unfortunately happen in rare cases, and we want our eye protection to be able to protect us from that. Another property we're obviously looking for is transparency. we're going to want to be able to look through the glasses. We're going to want to be able to see through them. And so we're typically going to want our glasses to be colorless and really highly transparent.
So these safety glasses then being colorless and transparent, where you can see through them very, very clearly, are then different from sunglasses, right? So sunglasses like we have here, like Dominic has, like I'm holding up, right, are actually tinted, and if you actually look through them, right, you can see that they're tinted there. And really this is to really kind of selectively remove sections of the visible spectrum and really decrease the intensity of the light that is entering through the lens. So that's a bit of a different goal than what you would typically have for a safety glasses lens that you would use in the lab. So in terms of thinking about most safety glasses being clear, I think the next question really is that are there any exceptions to having colorless lenses for safety glasses?
Yeah, that's actually a really interesting point there. As mentioned, almost all safety glasses are going to be colorless, like these ones here. But there's a pretty notable exception, which is safety glasses we're going to use when we're working with lasers. In those particular cases, the laser safety glasses, I have a pair here, they're pretty strongly tinted, right? You can see these ones here are really, really dark and red, okay? And the tint is actually designed, to match the color of laser light we're going to be working with. So it kind of leads to an interesting question of how do we pick the color for the glasses, for laser work, right? And so we sort of have this nice red pair here of laser safety glasses. So we're going to imagine that we're going to be removing some parts of the visible spectrum, but obviously there's still a color to it, so we're letting some other parts through. Now, instinctively, we see red glasses. We might think that that's, a great match for red lasers. I'm sort of going to do a little bit of a demo here, and we'll actually see that, that's not quite the case. So if we have our red laser here, so this is a red laser pointer, you can see here that if I move the lens through, okay, the lens is actually hitting the red laser light, and the light's really going through almost unchanged here. On the flip side, if I sort of have this green laser dot here, as I move the lens into the light, it actually very effectively blocks that, right? So in that case there, the color of the lens does not actually match, match the color of the laser that we want to be working with. We're trying to protect our eyes. We're trying to remove the laser light from hitting our eyes. And so, that leads to the question of how do we pick the color of the lens to match the color of the actual, laser that we're working with.
Right, and that's where the color wheel comes in and really offers us good guidance here in terms of how this works. So it turns out that colors that are opposing each other, so colors on opposite sides of the color wheel, are what we refer to as complementary colors. And if we have a lens material that absorbs or removes one color, then that object is going to appear to have the complementary color, right? So if we have light shining through these red lenses, or these lenses that Dominic is holding up for the demo, these glasses are actually absorbing the green light, and so these glasses then appear to have the red color because red is complementary or opposing on opposite side of the color wheel from the green. So whenever you have red safety glasses, those are going to be safety glasses that are going to absorb green light, and that you would use those with those green lasers.
Yeah, that's actually really great explanation there. So I guess it gets us to the question of what are most safety glasses and safety goggles made of?
So most safety glasses and goggles, so the goggles I have here, and then these safety glasses that I have here as well, these lenses are made of what's called polycarbonate. And so you can see the structure that Dominic has up on the screen there, polycarbonate. It's a polymer containing the carbonate group, and the linking is a unit based on a molecule called bisphenol A, or BPA. And so Dominic's going to pop up the structure of that monomer there. So you can see BPA there. And it's something that, that some of our viewers may have heard about.
Yeah, Absolutely. You know, so you know, why is there BPA in polycarbonate, right? So what does that kind of mean?
Right. So the PPA is there, and it's actually it's meant for in the processing and actual production of the polycarbonate. And this processing is actually designed so that there's essentially no unreacted BPA, and that the BPA there is actually locked into the polymer structure. And really, this is a common feature of most commodity polymers and plastics that are made. The processes that are used essentially ensure that there are no unreacted starting materials left over at the end of the polymerization. And so, I think our viewers may have heard a lot about PPA and the dangers of it. And why is that?
Right. So BPA obviously, in the small molecule or the monomer form, has been associated with lots of, negative health consequences as well as, potentially affecting, you know, the endocrine system. But, by the time we put it in a big molecule or a large polymer, typically a lot of the, you know, harmful effects just not present. And that's because the polymer is so high in molecular weight, such a large polymer that one, the BPA is not actually free to interact with the biological system because it's part of this bigger molecule. And as well as that, even if it was interacting with biological species, it's so big it doesn't really get readily absorbed into the cells, right? And that's pretty common for a lot of polymers. A lot of the time, the small molecule counterparts that make up the big molecule can be quite, potentially harmful. But by the time we make a polymer of several, thousands or hundreds of units long, it's simply all those small molecules, you know, become effectively a part of the bigger material and no longer available to leach into the biological system. And so the polymer is not particularly harmful, but a lot of the time, if you get some degradation of that polymer back to the small molecules, that can again release potentially harmful compounds.
Right. So if we're getting some breakdown of the polycarbonate, we may have some issues with release of products such as BPA. But in terms of maybe going back and thinking a little bit more about polycarbonate and what it's used for, where else can we find polycarbonate other than just safety glasses and safety goggles?
Yeah, polycarbonate is really commonly encountered in lots of applications that people may have encountered a lot or still continue to do so. So CDs and DVDs, so that actual transparent material that you have, that's actually very commonly made out of polycarbonate. Because the material is transparent, it can actually be really useful for things like plastic windows or even in greenhouses. And in fact, a lot of big storage bottles are made of, uh, polycarbonate. So those big water jugs that are present in offices, those big water bottles are actually often made of polycarbonate. And even some capsules and windows in aerospace applications can be made of polycarbonate. So it's a really versatile material.
So that's really interesting. I mean, so you have this really versatile material, but what are the properties of polycarbonate that really make it so useful in so many of these applications?
Yeah, it's actually really interesting. And one of the most fascinating features of polycarbonate is that it's actually almost completely transparent throughout the whole range of visible light. So that's why these safety glasses are, essentially colorless. They're completely letting through almost all wavelengths of light. But as soon as we start approaching that UV part of the spectrum, the polycarbonate absorbs really strongly. So they really absorb UV light. They let through a lot of visible light. It's a really interesting feature of polycarbonate.
Yeah, that's really interesting, right? And so what it means is that it's really this polycarbonate material that's absorbing most or almost all of the UV radiation or UV wavelengths of light, but letting through all the visible light. And so this is why with sunglasses, right, like this set that I have here, the set that Dominic has, why so many of these sunglasses really claim to be able to absorb or effectively absorb almost all UV radiation. It's typically it's the lens material itself. It's the polycarbonate lens material itself that's actually doing the job there of absorbing the UV radiation.
Yeah, that's actually really interesting. So in fact, these safety glasses probably have very similar UV transparency properties to your sunglasses. Another really interesting property is that polycarbonate is a thermoplastic, right? That's a term that essentially means that we can plasticize or make the material flow above a certain temperature. So, at room temperature, our safety glasses behave effectively as a solid, right? It's not strictly solid, it's a glass. So it's a liquid where the molecules within this are just stop moving. So they're just not structured, but they're not flowing either, right?
So why is that glass property or glass-like property so important?
Yeah, it's actually really interesting. So first of all, structurally, glasses behave like solids, right? So that means, it maintains its shape. As soon as we're below that temperature, we're able to make the material pretty rigid. And that gives a lot of advantages in terms of, processing, right? So same way as with regular glass, we can heat these materials. We can make them flow and make that into a liquid-like structure. And, that's been used for, many hundreds or, even more years in the age-old art of glass blowing, right? In glass blowing, you take traditional silica glass, you heat it up to a certain temperature, and the material begins to flow, so you can actually blow into it or reshape it to make useful structures, or sometimes just appealing structures or attractive structures. Like, a lot of art is actually made out of, glass blowing techniques. Using that sort of idea, we can take our polycarbonate, we can heat it up, make it flow, okay? And we can shape the material to whatever application we want. So it can be safety glasses, we can turn it into a CD, a water bottle, really any shape we want. Then the nice thing about that is we can process it warm, so we can actually have it flow, and then we can cool it right back down. And that material should really keep that shape forever, as far as we can tell. So, it kind of gets to the next type of material. We've already discussed a bit about safety glasses and safety goggles that are made out of polycarbonate. What about face shields? What are those made of?
Right. So face shields take a number of different forms. I have one form here that our viewers might recognize as having been manufactured in a number of places recently. If you take the more durable sort of long-term use face shields, a lot of times those will be made of a polycarbonate clear shield in the front. Those are very, very durable. But with the recent pandemic, the recent COVID pandemic, in response to that, there have been a number of people that have developed 3D printable frames, just like I have here in red, that we can actually pair with transparencies. And so this 3D printed frame is typically made of something called polylactic acid, which is the structure that Dominic has there. You can actually include different colored dyes in with that plastic to give the plastic different colors. And that makes these frames really easy and fairly quick to produce. All you need is the polylactic polymer filament and a 3D printer. Download the file for the actual frame itself, and then you can go ahead and print it off yourself. So we're actually going to include a link from the National Institutes of Health 3D Print Exchange. We're going to include a link to one of these face shield frames in the comments for the YouTube video. So beyond the actual frame itself, we then have the transparent part of this this face shield, and this is actually just one of those overhead transparencies that some of our viewers may recognize, particularly from their early school years, right? And it's these are typically made of what's called cellulose acetate, and that's the structure that Dominic has shown here. So it's cellulose, where each of the glucose monomers within there has been modified to have numerous acetate groups on it.
Yeah, that's actually really interesting there. So that basically means that, you know, anyone with access to a 3D printer, some elastic and some overhead transparency can actually make their own face shields, which is actually pretty neat.
Right, and so we'll, like I mentioned, we're going to include a link to the shield in the comments, and as long as you have a 3D printer, those coordinates and then the face shield, that transparency, and a little piece of elastic, you can make your own face shields at home.
Yeah, so we hope you enjoyed our series on polymers we encounter every day, and this video really focusing on polymers in PP applications, especially eye protection type applications.
Right, and in our next video, we're going to look at polymers that are used to absorb energy with applications ranging from cushioning impacts to ear protection. So hope you enjoyed the video, and we will catch you on the next one.